Hello, ladies and gentlemen. Let's talk about Chapter 12 really quick for you here. We're not doing all of Chapter 12 right now. We're just going to focus on a little piece of it that has to do with soil. So let's chit-chat about that. So, soil. It's really important in ecology to understand soil because it's kind of the foundation of land-based ecology stuff. And so, soil is this complex mixture of a lot of different things. It's got all of the things that are listed down here. And so we should keep all those in mind as we work our way forward. It is pieces of rocks. There are minerals present. There's dead organic junk there. There's water, air, and then, of course, a lot of living microorganisms and decomposers present that are doing a lot within the soil. And so it's a combination of all those different things. So soil is kind of a living entity of sorts. And so it is considered a renewable resource. And so we should treat it as such. It does replace itself. Now, depending on where it's at, it replaces itself at vastly different rates. And so in some cases, it can take a century or more, even in some cases, to get just 1 centimeter of soil. And so not quick to replenish itself. And so other places soil forms really quickly, some places it does slowly. So it is a renewable resource as long as we're not degrading it at too fast of a rate, which unfortunately we are in some cases. So it is the basis for all life on land, soil is. And you'll see that it's how plants, producers get most of their nutrients that then move on to consumers. It's not the only place, but they get the vast majority of the nutrients from the soil. Here's the part where we come in, human agricultural activities. We, unfortunately, by our modern practices such as this tractor work down here, we cause a lot of soil erosion. And so in many cases, we're making this thing, soil, a non-renewable resource because of modern farming practices causing a degradation to that natural capital. And so we have to be careful about how and what we choose to do with our soil just to make sure that we're maintaining it. Now, when we talk about a mature soil, and that's the one we care about for agriculture, it has a series of different layers in it. These are called soil horizons. And so, sorry, hit a button. They're called soil horizons, and so you guys need to know these different layers. And so they're not necessarily in alphabetical order because O comes first, but after that they are. So O is the first layer, and it's all the dead organic junk on top, basically, leaves and twigs and all that jazz. Once you get down into the actual soil part, then it goes alphabetically. A, B, C. A is topsoil. This is the stuff that we care about for growing crops. It's composed of what they call humus. Humus is kind of partly broken down dead decay stuff. It's what gives it kind of a rich color a lot of the times. Potting soil is mostly all humus. It retains moisture well. It has a lot of nutrients and minerals present in it. So the topsoil, horizon A, is essential to pay attention to, especially when we talk about agriculture. Horizon B, also known as the subsoil, is mostly just broken up chunks of rock. Little teeny tiny pieces, sand, silt, clay, that kind of stuff. It's not very full of organic stuff. There's not very many organic material pieces in the horizon B. C is bedrock. We're down there where we don't got anything. It's pretty much unweathered parent rock. So all of these layers can vary in size greatly. There are places around here where the bedrock is hundreds of feet underground. Horizon B is hundreds of feet of ancient volcanic ash in lots of cases, especially east of town here. And then A is a very thin layer of maybe an inch or two at most of soil. And then horizon O could be anywhere from almost non-existent to pretty intense depending on where you're at. So they vary in amounts greatly. This shows a picture of kind of the movement of immature soil up to that stage where you have these 4 horizons right here. This box right here shows you a very mature bunch of soil. So the bedrock's well down here. You have a lot of subsoil. Then your topsoil is decently thick, and then you have that leaf litter on top. Younger soil and immature soil doesn't have that. It's mostly broken up dead rocks with very little organic material on top, mostly mosses or lichens. And so this is the process of succession, which we'll talk about in more detail as we move forward. Primary and secondary successions result in then moss and lichens, and then you get grasses and shrubs, which then can increase the organic material present, getting you better and better A horizon. And then here we have a nice mature soil for taking care of good quality growth like forests and things along those lines. This is the same kind of thing, showing you pictures of all of those different horizons. This is your topsoil, your subsoil, your bedrock. And here's an actual picture of it as well. So it looks different in different places. There are thousands of variations, but nonetheless, those are your four main categories. Next, let's chit-chat really quick about these two terms, infiltration and leaching. And we need to pay close attention to both of those because they are both naturally occurring things, but there are things that we as humans increase and decrease within a soil system that could create problems. So infiltration is just when water works its way downward into the ground. So that's what these blue pictures are showing you, infiltration. Infiltration in some cases naturally happens really, really quickly. In other places it happens slowly. So these big arrows are showing a lot of infiltration, and down here it's showing very little infiltration into the soil. The second part of that is leaching. Now what leaching does is, as the water moves through the soil, a lot of times it will dissolve minerals and organic materials from the upper layer, the topsoil, and it will move it or wash it down into these lower layers. The problem with that is when you take those organic materials out of the upper layers, then things can't grow. They need that to grow, and so if their roots can't go deep enough to get down in here, it creates problems. So leaching of the soil is really a problematic thing that we need to be aware of. Infiltration rates can be affected by the amount of moisture or amount of organic material on the surface, but mainly it's because of different types of soil. The types of soil determine how much infiltration rate you have. Clay, water can't really infiltrate at all. Sand infiltrates rather quickly, depending on the porosity, how much it's compacted, all of those kind of things. Permeability are things that affect the rate of those two things, but we have to keep those in mind so we can best understand how to keep our soil healthy. Soil profiles. So if you were to look at different biomes on the planet, they constitute kind of different types of soils in those different places, different amounts of each horizon. Some of the best soil on the planet we have exposed to make into cropland, which makes sense, right? You want to grow your crops where there's really good soil. And so what we do is we chop down deciduous forests. We have removed like 80% of the deciduous forests in the United States. They used to run all the way from the East Coast all the way out there past the Mississippi River. And now if you drive through there, there's little patches of them, but most of them have been cut down for farmland. Grasslands are another place where the soil is pretty solid in those places, and we are changing grasslands into agricultural places. And then we usually get water from underground wells or whatever to supplement that. That's why they're usually grasslands, is the amount of moisture they're getting. And so we pump water in this case a lot of the times to get that extra bit of stuff. Boreal forests can have okay soil content. It's usually high in acid because of the nature of what it is. Deserts, soil is not necessarily as great as you think it would be, and it, of course, comes together really slowly. It doesn't grow very fast because there's not a lot of water to help with the erosion process. Rainforests. Some people think rainforests have great soil, but the reality is the amount of minerals and nutrients in rainforest soil is extremely low. It spends all of it, the minerals and nutrients. There's such a competition among the plants up here to fight for nutrients that the soil itself has very, very little in it. Most of it exists in the biomass itself. And that's the problem with deforestation in the rainforest. Most of the rainforest trees are being cut down so people can grow crops there. indigenous peoples. And so what they do is they cut them down, they slash and burn it. The burning of the forest puts enough nutrients in there for about 1 year's, maybe 2 years worth of crops. And then there's no more nutrients available in the soil, and so they must move on and cut down more rainforest for cropland. And so it's an ongoing process of finding places, slashing and burning, trying to find places to grow crops, and it's a constant moving process. But as a result, they're cutting down or destroying that biodiversity, which creates its own problem. But the soil itself isn't fabulous. This is a quick map of a lot of the different types of soils on the planet. We don't get into all the detailed types that are listed here, but you should know that it is extremely wide and varied. There's 15,000 different types of soil just in the United States alone. And so it's a very complex thing to know, to understand, and people spend their entire careers just working on soils. When it comes to soils, we care about the soil properties themselves. And what I mean by that is the soil properties tell us a lot about soil, what it can be used for, what's good about it, what maximizes growing, all that kind of stuff. If you're in ag, you probably have studied all this stuff in detail. The texture of the soil, the particle size, how much water it will hold, how much goody organics are in it, what its density is, its fertility, porosity, and permeability. We're going to work on the soil lab, kind of working our way through these terms. But you should know what some of them are up front. Porosity. Pore is how much space is in between the grains and pieces. This has to do with how much water. Say if you filled up a thing with soil, how much water could you add to it? Some things are packed very tightly together and there's no space in between, and other times there's lots of space or pores in between. So porosity is that term. Permeability is the rate at which or how water can move through the soil. If you pour water on top, can eventually leak out the bottom or not. Some soils, permeability is really not very permeable at all. Other places it's very permeable. These are the three most important things when it comes to fertility, because these are the things that plants need for growth. They need the right pH balance. They need potassium, phosphorus, and sodium. Or nitrogen. Weird. It should be sodium. In the soil. Nitrogen too. And if you have the proper amounts of some of those things, then what you'll do is you'll gain your fertility. Density is an indication of some things. Organic material, of course, matters. But these are some of the first things that we test when we talk about soil properties that matter. These ones and then these two are the ones that we usually run tests on. And then moisture content varies, of course, whether it rains or it doesn't rain or whatever. But its ability to hold moisture is the more important thing. That's soils in a nutshell. Thanks.